All right, we've got a great question here from Reddit user TheAmericanJuan in the Learn Math subreddit. And let's see, so I came across this proof while trying to finish a math packet I'm trying to finish. Okay, so he figured out that the triangles are similar, but then he couldn't actually get to the end. So I may not take the exact route that you were taking, but let's see if we can get a proof for this. So we're given that D is the midpoint of AC. So here's D, and it's the midpoint of this triangle, and then E is the midpoint of BC. Okay, here's E, it's the midpoint of this side. So D is the midpoint of this side, E is the midpoint of this side, and then they have this included angle C here. And so we are to use those facts to prove that the ratio of CD to CA is equal to the ratio of DE to AB, okay? So we need to prove similarity, and then that will be like a stepping stone to get us there. So let me, actually maybe I can just insert this. Save this guy. Actually, where am I gonna save this? Let me pause it. Okay, so I drew this up here. So we have triangle, let me just, I'm pointing at the screen. You stay here. We have the triangle ACB, and then on side AC I've drawn D, and we're going to call that the midpoint. And then we have CB with E as the midpoint there. And so we want to prove that CA is proportional, CA relative to CD is equal to, no, that's not right. Okay, CA, yeah, to CD. Let me just look. Let's go back. CD to CA, okay, that was right, is equal to DE to AB. So the ratio of the corresponding sides is equal. Okay, and we can get that directly from their the similarity of those two triangles. So let me just shrink this down. We're going to keep it as a visual reference, but we don't really need it anymore. Then I'll put it up here. All right. We'll go back to pen here. So, given D is midpoint of CA, and E is midpoint of CB. Okay. And then we are to prove that the ratio of CD to CA is equal to the ratio of DE to AB, right? Yeah. Okay. So we can do like that, you know, two-column thing that most geometry classes do, where you make the statement and the justification. I don't really like doing it that way, but you know, let's do it. So D is midpoint of CA, and E is midpoint of CB, and that's by given. Let's call that 1, call this 1. Okay, so we need to make 2. So what do we get from that being the midpoint? That means that CD is equal to 1/2 of CA. And likewise, let's see, CE is equal to 1/2, sorry, I'm running out of room, of CB. Our justification is their definition of a midpoint. All right, and then we can go on to say that, we can say that, say, angle C is congruent to angle C, so we're trying to angles congruent to themselves. Oops. We're trying to say that the triangle DCE is similar to ACB, so that we can get the ratio of those sides. And so we have, I think this is everything we need for side angle side. So we can say that triangle A, write the triangle ACB is similar to triangle DCE by side angle side. So I just paused it to think about this for a second, and I actually want to say one more thing in here before I say this, because it may not be obvious to whoever is reading your proof that this is true. So let's look at, so we can say since CD is equal to 1/2 CA, then the ratio of CD to CE is equal to 1/2 CA over 1/2 CB. And then this implies that CD to CE is equal to CA over CB. And this is by substitution. You can get more verbose with these, but I don't know how much is going to be necessary based on your professors, and this is just simplification. Okay, so now we have the ratio of these two sides equal, so we have enough for our side angle side. So then now we can say that triangle DCE is similar to triangle ACD. Oops. Okay. And this is by the side angle side theorem. So I think probably the picture-in-picture has us cut off now. So I'm going to erase this part, and then we can work over here a little bit again. So now that we have those two triangles similar, we can just, this is the last statement we need, we can say that we can say CD relative to CA is equal to DE relative to AB, because the ratio of corresponding angles, so the ratio of corresponding sides of similar triangles are equal. And so, when you do this, make it a little bit neater. Obviously, I'm not getting graded on this work, but that's the rationale. And you may even want to consider one additional line in here saying that, you could say something like CD to CE is equal to CD to CE, which is just a property of equality, right? Things are equal to themselves. And that'll allow you to then use this substitution. So optional step in there. I mean, maybe if you're trying to be as like thorough and rigorous and pedantic as possible, that might be a good thing to do. But it kind of depends on what your teacher is looking for. So hopefully this helped. If there's anything unclear, just send me, you can reply in the Reddit thread or in the video comments, and I'll get back and update another video. And please consider subscribing to the channel. So I'm going to do a homework help thing in the evenings. I think I'm going to start relatively soon if people are interested in that. So thanks.